Hello, everyone. Good morning, afternoon, and evening to all of the people alive or maybe watching this stream later. So we are here again with another session of the Microsoft Zero to Hero. My name is Puya, Microsoft MVP, MCT, and Community Leader, Microsoft Hero. This is the last sessions of APAC series sessions during August. Of course, we have more sessions during September. We have great speakers coming up. Before actually just having AJ on the stage, I'm just going to the couple of actually community rules and updates, and then we have AJ on the stage. So first of all, you definitely heard before about the Microsoft Learn and what Microsoft Learn has. So that's a great community to learn and just collaborate with other people and other experts and making sure you are on the right path. You're learning a lot from the Microsoft technologies. So make sure you take advantage of the Microsoft Learning Rooms, especially Microsoft Communities, which is recently moving from the Learning Rooms now to the Microsoft Tech Communities. Microsoft Zero Hero, also Microsoft Hero, just moved to that Microsoft Tech Communities. You can find us there. Just a very quick code of conduct of the community. So be aware of the actually others. The same as other communities, we are trying actually to make sure everyone to be friendly and respectful to one another, listen different opinions, and be kind and patient when asking or answering the questions. Without further delay, I would love actually go to the slide of and having AJ on the stage. So make sure you follow us. So please join me welcoming AJ on the stage. He will be guiding us actually to the data, is talking about actually revolutionizing DevOps with AI from the pipeline to deployment. Then don't forget to follow us on the LinkedIn and YouTube and everywhere. So AJ, great to have you today here. How are you?
Yeah, great to be here. Thanks, Pia. Thanks for that lovely intro.
Awesome. Thank you for your time and having this session to share your knowledge actually with other people around the world pretty much. So please, if you're comfortable, share your screen and I'm going to add to the stage. I'm going to be behind of the stage. And then if you need any help, I will be able to be behind of the stage.
Yeah, great. All right, I'll begin sharing. So we'll give that a minute to come through.
Here you go.
Yeah,
that's cool. Your slide. Thank you.
Yep. Awesome. So, thanks, Pia. I haven't figured out how to go into presentation mode and sharing, so we're just going to do it like this. Hopefully that's readable for everybody who's live and watching, or for those who are watching it later. So a little bit about myself, just quickly. My name's AJ Bajada. I am all about Azure, DevOps, and automation. And of course, as you can probably tell from what I'm wearing and my background here, I'm a big Star Wars fan. So if you ever want to talk about any of those topics, I'm more than happy to spend lots of hours talking about those. There's also a QR code there. Feel free to scan that. That will take you direct to my GitHub page. All the demos and recordings and things I'm doing today. There's a repository on there for this as well, so you can refer to those later as well. Okay, so let's get started. In terms of what's on the cards for today, we're going to go through building AI-powered DevOps pipelines, talk about lint testing, talk about when we're actually deploying Azure AI infrastructure and models. And we're also going to end on talking about PS rule for Azure and what that's all about. So first, let's start with building AI-powered DevOps pipelines. So to begin with, first, like, what are DevOps pipelines? So DevOps pipelines are a series of automated processes that essentially help development and operations teams build, test, and deploy software. Is essentially the crux of it. It's designed to be streamlined so the software development cycle can deliver faster and to a higher quality as well. So then if you're referring to, like, what are we talking about DevOps pipelines? If I mention DevOps pipelines, that's exactly what I'm talking about. So what are some of the challenges we have with traditional DevOps pipelines today? Typically, we find we're doing repetitive manual tasks. Now, these tasks are time consuming. These are things like writing scripts or repeating like boilerplate code, those sorts of things. As you could imagine, as humans, we make errors, so we can misconfigure things. We could deploy things manually, and all those sorts of things increase the risk of failures. It could be we could over or under provision pipelines and compute resources behind the scenes, which can have a flow-on effect to impact the overall performance of deployments and go live times, those sorts of things. And testing, everyone loves testing, right? So there's always challenges with that. So testing could take time to create tests. Typically not everyone's favorite thing to do. Or we could write tests that don't really cover all the scenarios it should. Again, could be delayed and those sorts of things that cause a flow-on effect, cause more delays, prioritizing, bug fixes and, improving the quality of, your software delivery. So then came AI. So in October 2021, that's when GitHub Copilot was first released for general use. And it was really basic when it first came out. I mean, there was other AI tools around, but this is when GitHub Copilot specifically came out, and it was pretty much just an autocomplete tool. For those who used it when it first came out, like myself, it wasn't really feature-rich as it is today. And it could really just, do autocomplete and things like that. It couldn't really do all sorts of fancy bells and whistles that it has today. And then later on, Copilot Chat got introduced. So that kind of then really changed the AI world, where you could actually have a conversation with your code, essentially, with your AI partner there, and say, help me fix things, explain this code in natural language, and actually ask questions about your code base, and it would return results for you. So it really changed the world and how we work today. Now, you may have heard the term vibe coding. So, when I first heard vibe coding, I thought it was, typically what I do is I usually have something playing in the background that I'm writing some code, typically Star Wars or something. And I'm like, yeah, just coding away. So I was mistaken. That's not what vibe coding is. It's essentially when you're actually not writing any code, you're actually using AI to actually develop the code for you, and you're just describing the problem in a few sentences, which is known as a prompt. So this is what allows software to be quickly created and debugged, and enable you to essentially take an idea to a prototype really quickly without being bogged down on trying to figure out how to actually write the line of code and generate the code yourself. So vibe coding has become much popular since AI has really come to life. You may have heard the word agentic AI, or agents, or agent AI, any of those combinations. They've really become really popular and really well known in the last few months, maybe started this year, if you will. So essentially, when it comes to agentic AI, it's when it actually exhibits autonomy itself. So it actually has a goal, it develops, it repeats, and it adapts and reiterates. If you go from like auto completion days to even just Copilot Chat, when it first came around, it was you would ask it something, it would return a message, or it might spit back some code for you. Then you would take that and you copy and paste it, tune it. Agentic AI really takes it to the next level, where it actually reiterate on itself. It'll say, it'll generate some code, it'll actually create files for you. It'll actually really takes a bit more of control and takes the driver's seat for for all intents and purposes, and helps you get to the next level and build that software with you're still overseeing it. It hasn't gone off and done it all, taken complete control, but it has helped you go into the kind of the next level. So it essentially writes its own code, it tests it, handles it, refactors it, generates docs all on its own. It's completely autonomous. So how do we get AI integrated into our pipelines? So when we talk about code completion and pipeline script generation is typically one way to help you complete your code faster and actually help generate your pipelines. So you have tools like GitHub Copilot, which can now just quickly auto-generate YAML scripts and pipelines, which really streamline how quickly you spin up a pipeline and reducing those errors, because they're so well known. It has all the trained data to refer to. Tests, like I mentioned, not typically everyone's favorite thing to do. AI can really help speed that up, create unit tests, integration tests, end-to-end tests, all those sorts of test cases by just analyzing all your code and code changes and really prioritizing areas that really need that test coverage to make it more efficient. It also can help with error detection and debugging. It can analyze all your code, your source code, your pipelines, look for areas where that can, essentially need debugging, or saying, hey, this is not performant or this is inefficient code. You should really refactor that and improve it for you. And on the monitoring and continuous improvement side, AI can actually help identify all sorts of things from like performance metrics to provide things you can actually action and refine your pipeline configurations ahead of the time. So by the time you actually get it in, your code's up to speed and it has all those improvements to kind of reduce errors and make sure it's performant as it should be. So building pipelines with code completion. So as I mentioned, when GitHub Copilot first came out, this is essentially what you could do. There was kind of two forms. You could write some lines of code, and then you'll see that ghost text that I've got kind of on the screen there. And then you can kind of like press tab and it will auto complete for you. The other way you could do is at the top, you can put in comments saying exactly what you wanted to do to kind of, build a bit of a story to say, hey, I want you to create me, in this case, a GitHub workflow that runs on push and deploys to production. It needs to be called this. The workflow should use the latest version, et cetera, et cetera. So whatever your objectives and what do you want the configuration to be, and then it will give you enough context. So then when it does its autocomplete, it will actually use that context. So that's when GitHub Copilot first started. That's really what it wholly and solely could do. Then in came GitHub Copilot Chat, like I mentioned, where you can actually say, hey, give it a prompt, and it'll actually spit back something for you. So in this case, hey, create me a reusable workflow that deploys an Azure App Service using .NET. And you can actually, for those who are familiar with prompt engineering, you can actually give it examples, or you can give it a file to reference and say, hey, use this as an example so it knows how to structure your code so you can align to kind of how you want it to code to your standards a little bit. There's other things you can do now with like Git Copilot instruction files and all sorts of things, but this is a good practice in terms of a good mechanism to use when you're prompt engineering as well. So that's another way you could use build pipelines with chat. You can quickly do that, as you can see, and what's highlighted in the green is what it's come back with. And then we talk about agents. So it's all about agents nowadays. So that essentially takes GitHub Copilot Chat to the next level, where it can continue to reiterate and change files and execute terminal commands and do all sorts of things depending on what you want it to do. So in this case, I said, hey, can you create me a Star Wars collectible store app based on Python? And away it went, and it started creating a whole bunch of files, a project, and all sorts of things, and documentation. You can see here, I even created a Copilot instructions file. It created the app py file and a README file for me. And then I have the option to accept that or iterate on changes, and you can have that conversation with it and keep going till you get your end result. So that's what I mean with building pipelines with agents. So you have a few different options depending on what your preference is and where you want to go. So let's have a look at that and I'll unpack it a little bit. So what I'll do is I'll switch screens. So I might be switching from the slides to my actual code and web browser, so just bear with me. So I'll do that now. So what I want to do is just show you how we can do some DevOps pipelines, and then I want to show you how we can actually build an Azure application using AI itself as well. So let me just bring that up, and then I'll share it with you. So just bear with me. Okay. So just trying to find the share button. Here it is. Okay. Cool. I think that's come through now. Fantastic. So on my screen, what I'll do is I'll show an example of code completion that I mentioned earlier. Then I'll show an example of vibe coding, and then we'll go into kind of a bit more fancy deployment with deploying onto Azure as well. So this is, like I mentioned, similar to what I had on the example before. You can see I've got some comments here. I'm saying create a GitHub action that runs on push to main and on a pull request. The action should deploy a web app to Azure and should consist of a web app, a React front end and a Node.js backend with a MongoDB database, et cetera, et cetera. I'm not going to read all the lines, but you kind of get it, right? So it should have a name of autocomplete. So you can see the ghost text auto has generated for me. So now I can press tab and I can press enter, and it will keep going. So sometimes it'll take a minute. There you go. I have to press enter. Sometimes you find if it doesn't really wake up, just minimize my terminal. If it doesn't really wake up, I'll close this and I might zoom in a bit. Maybe too much there. You can try just typing some keywords, and that usually wakes it up. So if you're familiar with, YAML, and this is a GitHub action, so you've typed like trigger, or in this case on, depending on whatever it is, some keywords usually wake up the AI or GitHub Copilot to do its thing. So you can see I can press tab. Oh no, I kind of actually, yeah, there we go. So then it's gone ahead and it's giving me an option whether I want to accept that. For this case, I'm just going to go yes. That looks good, just so we can see it. Close that message. So you can see here, it's setting up a Node.js, it's installing some dependencies, it's even running some tests. It's publishing those artifacts, and then it's got doing a deployment job, authenticating to Azure with some secrets, and then it's going to deploy that web app. So that's one quick example on, if you're using autocomplete, how you can quickly generate a DevOps pipeline using autocomplete if you give it the context. So that's one example there. So another one is, I've got a prompt here, and we're going to put it into GitHub Copilot chat, and we're going to see what it comes back with. So if we put in an example here, kind of similar. I'm going to open up GitHub Copilot. I'm just going to make sure it's in ask mode, because we have different modes now. So in this case, I'm just purely want chat. So I'm going to say here, create me a GitHub action that deploys my app. So for those who don't know, you can actually use / for commands in GitHub Copilot, and you can actually use the hash file to kind of reference files. Sorry, the hash symbol to reference files. So you can see here, it's brought up files in my workspace, and there's also all sorts of things you can do. You can also drag and drop files as well. So if you're wondering, hey, if you want to say reference, I don't know, because I'm only in a single workspace at the moment, but if I want to say reference this JSON file, you can actually drop it in there. You can see now it's actually in there and it has that context. So there's lots of different things you can do to kind of give it examples now and drop in from GitHub Copilot. Oh, let me just close that because it's trying to read the schema there. I'll just give that a minute to catch up. But there's lots of different ways you can give it context now, so it can understand during your prompt what it should reference. So yeah, I could say great make GitHub action that deploys my app, deploys web app onto Azure. Now I created a very basic prompt on purpose. So I'm expecting, a kind of vague result. So what you want to do is give it as much context as possible using those kind of file commands and references saying use this structure, all those sorts of things. So it has enough context so it understands what it's trying to do. So you can see at the moment, it's trying to read my app folder. It's using a lot of assumptions. So it doesn't have a lot of knowledge on what it's expected to do. So it's going to go and basically essentially try and figure it out itself and do as much as it can, saying, hey, is this what you actually wanted? Do you want me to proceed? And this is what it's actually going to look like. And here's the example, right? You can see here, it's sort of similar to what was done in the previous one, where it's going to say, hey, check out the action, set up node, install dependencies, build the app, run some tests, log into Azure, deploy, and then log out. So it's quite a little bit different because the other one had like a build and deploy job where this one didn't. If I had a file that I referenced, I could say, that had that build and deploy jobs, then it would use that that kind of same structure. So that's how you could kind of, and I could keep going here, keep going saying change this, change that. And this is an example of vibe coding where you'll just keep going back and forth till you get what you want, and then you go ahead and you can kind of execute and deploy. Cool. So that is an example of the autocomplete and vibe coding options you have. So I've kind of set up this web application myself. And what I'm going to do today is we're going to deploy it to Azure. So in here, I have a web application, and it is a kind of a typical kind of pattern. It's a React front end with the Node.js backend and a MongoDB database. And of course, it's Star Wars related. So it's a Star Wars collectible like sort of website, very basic, just a few different pages just for a demo. So what we're going to do today is I've split up some infrastructure in Azure. And what we're going to do is I'm going to deploy the app to Azure now, and then because it does take a few minutes. So I'll show you that now. I'll switch to my web browser so you can see the app running in Azure, just to prove that it's running and it's not actually live. So just bear with me while I do that. And I'm going to share this tab. Okay, hopefully that's come through. I've got red borders around, so that's looking good. Cool, so this is the Azure infrastructure that I deployed. You can see here, this is my Azure, and it has an app service plan with the API, and it's got a MongoDB database, and it has this static web app, which will be the front end. So I'm actually going to go to this URL right here and share this tab so you can see it. You can see it's, once it's come through, you can see it's just a blank out of the box website from Azure that there's nothing on there. So what I'm going to do now is I'm going to run the pipeline that was vibe coded to deploy, and then I'll show you what the code looks like while it's running. And then we'll come back to it, and hopefully this should be now a Star Wars, Star Wars web store website. So let me switch to, cool, I'll just give that a minute. So I'm just switching to my github.com where I deployed the infrastructure. So this is where you will see I've deployed the Azure infrastructure. So I deployed that earlier this morning, 11 hours ago. It took about 4 minutes. So what I'm going to do now is actually going to deploy the application itself, and this will deploy the web app. As you can see, I've already run it before just to test it, but we're going to deploy it again. So let me just run that now. Okay, so that's running. So we'll come back to that. Hopefully no errors, no reds. Okay, so I'm going to go back to my VS Code and I'll explain what we're expecting from my code, and I'll show you how it kind of works. Apologies for the chopping and changing. Okay. Okay, so I am in this now. So what you can actually do, if you were new to this like project, you can actually use GitHub Copilot to explain it to you, or say, hey, how do I actually start this thing locally? So I'm actually going to do that myself. For those that don't know, /clear, which can clear the existing history if you wanted to know that. Some people don't know about it, so I like to tell people about it. So I'm going to switch to agent mode. So I'm in agent mode now. So I'm going to say, I'm just going to give it a prompt saying, hey, can you help me start this? Can you help me start this app locally? That's all I'm going to give it. I want to see how good it is and how can it actually figure it out itself. Now I know how to start this myself, but I just want to see how good it is. So it should do some analysis and it should review my code repository and try to figure out, well, hey, what is your app? What is it trying to do? Like, how does it work? What code is it based on? And saying, all right, this is what I think it is, and this is how I think it should be started. Those sorts of things. So I'm just going to give it a minute. So you can see it's processing in the background. It's reading the README files. It's reading all the files in the background. As you can see, it's looking up for dependencies and all sorts of stuff. So just give it a minute to do its analysis and see. So you can see right now, it's come back and saying, hey, it's a React app. It's a Node.js and it connects to MongoDB, which is all 100% correct. Now it's going to try and run a command in terminal to run the backend and install the dependencies. So I'm going to go ahead and say, yeah, go for it. So you can see now it's actually gone ahead and executed that command in my terminal. And it actually is now going to iterate on itself. So great. Now it's going to install the dependencies for the client because it's done it for the backend. Now it's going to do the same for the front end. So I'm going to say, yes, go ahead and do that yourself. So you can see now this is a great example of agent mode kind of operating and how you still have control, but it's actually doing all the work behind the scenes and you kind of just guiding it in the right direction. If it goes off on the wrong path, you can bring it back onto the right path as well. So we'll just give that a minute or so to do its thing. Great. Now it said, okay, now all the dependencies are working. I need to start the backend server. So that's exactly what it needs to do. And then it needs to start the front end. So no surprise. So you can see now the backend server is running. It's MongoDB is connected and it's running on port 5000, which is correct. So now it needs to go ahead and start the front end. So it's going to go ahead and do that. So I said, fantastic. So I'm going to say, yes, go ahead and do that. And now it's going to go ahead and it should automatically launch a web browser. You cannot see that. So I'm going to share. So I'll jump out of my terminal, but it is running because it just launched on my screen. And I'll show you this feedback first, then I'll switch to the web browser. It's running on localhost 5000. You'll see that in a minute. And it's saying, yes, it's all working good. So you can see I didn't tell it anything. It's just saying, hey, go figure it out. And now it's like, I figured it out and this is how you do it. And it's giving me all the information and the commands to do so. So it's pretty cool and pretty powerful. So let me just switch to the web browser so you could actually see what it looks like. This is my favorite demo, by the way. Where is it? This one. Okay, so this is running on localhost, 3000. I don't know if you can see the address, but it is. So this is our Star Wars collectibles web store. You can see it's running locally, it's running fine, right? I can click on different pages. You can see all my past orders, etc., right? It's very basic. I vibe coded this whole thing, which was pretty cool. And this is exactly what I want to get to on Azure. So remember, I showed you that site earlier. This is exactly what I want to get on Azure. So like one of the key things I do want to call out especially when you're doing like vibe coding is it's very unlikely you're going to get something working to like a production enterprise grade straight away in like the first shot. There is going to be a lot of iterating and going through and making sure things work, a lot of testing as well, especially for a production grade. If you're doing like a dev or like a POC, maybe less so. But some of the things I did run into when developing this app, like it took me a while. I didn't get this going in like one or two prompts with GitHub Copilot. It ran into there was a lot of pitfalls, especially like things when I wanted to call things. What I'll do is I'll switch tabs. I'll stay in the web browser. That way I'm not chopping and changing between VS Code and my web browser. So while that's running, I'll just show the code. This is just the same code I had cloned on github.com. So when I was creating the pipelines, for example, I really wanted when I deployed the Azure infrastructure, like all this was vibe coded as well. What I really wanted to do, what I play around with was when it created the MongoDB, I wanted to get the connection string, which it does here. And I wanted it to create as a secret in this repository. So I wanted to go ahead and create a GitHub secret and store that as a GitHub secret. So when I run my deploy Azure application pipeline, which I'm running right now, it'll actually read that secret in and know how to connect to my MongoDB in Azure. So when it deploys those things in Azure, I wanted to kind of be that kind of fluidity and kind of just all connect. And same with the static web app, like get the deploy token and store that as secrets. This it really struggled with when I first tried to do it. It would use like out of date, because it's based on its training data it has available. So it used like out of date like commands to connect to GitHub and things like that. And yeah, I really found that I had to really kind of guide it along the way before it will be able to do something like this. So it really used a different way to set secrets. So you can see here, it's actually from a command perspective, it's not actually a lot of lines of code. You really just need to authenticate to GitHub using GitHub CLI, and then you just run this gh secret set command. But it was using some other commands that was done previously. I think this is a newer way to do it. So just be aware of that. Like, those sorts of things have got to happen, especially when you're vibe coding, to make things essentially easy for yourself. So just be aware that there's going to be that, a bit of back and forth as well. So I found that was one of the things that I did find, like trying to get the code working to create GitHub secrets was one of the things that kind of stood out to me when I was developing this. But I had a lot of fun. It was really cool. Let's see how that's going in terms of that pipeline. Okay, so it's deployed. It's looking good. All green. Green is what we like to see. So now, if I go back to that web page, I haven't refreshed it, so I've left it on purpose. So I'm going to hit refresh. Sometimes what I have noticed is it does take a couple of minutes for all the connections to refresh. So I might get stuck with a loading page for a minute or two, but let's see how we go. I'm going to hit refresh now. Yeah, okay, so it has deployed something, and this is what I expected. It's got this loading page. So this I've noticed does take like a minute or two before it actually, connects to the DB and things and come live in Azure, but it does eventually work. But you can see at least it deployed something to Azure. And this was all vibe coded, like you could see, and it was all done via DevOps pipelines as well, which were all vibe coded as well. So that's some of the ways you can use AI in your pipelines to kind of generate things and actually get as in this case, an application onto Azure pretty quickly from locally developed into Azure using AI to assist you. Cool. I'll leave this here, and we'll come back to it in a minute. Just in the interest of time, because I tend to talk too much, and I do have a bit of content to get through. So let me go back to my slides. I might just share that, and I'll loop back to this at the end, and we'll do a refresh together, and hopefully that flicks over to what we saw before. All right. Okay, so we're back onto the slides. So now let's have a talk about linting. So the importance of linting. So what is linting? So for those of you who don't know, linting is essentially a process of scanning your code to detect errors, enforce style guidelines, formatting, quality, before your code even runs or deploys. So, for those who, code in Python, Python's all about indentations. And if you've coded in Python before, I am almost guaranteed that you would at least once run into an indentation error. Linters really help with that. When you automatically save your file or do all that formatting, or help you with the indentations. YAML is another culprit of mine that is always fond of indentations as well. So why is it essential? It saves time by catching all those issues before you even deploy your code, before you even merge your code. Reduces bugs, make sure it's smooth collaboration process for your developers, all that sort of stuff. You can see on this screenshot, linters already in my IDE picked up some things. You can see in this case it says, hey, you're missing some documentation here, you're missing a new line, all those sorts of things. So you can go in and update your code straight away in your IDE before you even merge it. So some pretty cool stuff there you can do with linting. Some of the benefits, as I kind of mentioned, improves your code readability and maintainability, makes it consistent, makes it clean. It detects errors before it gets into runtime. A bit of a preventative measure. It flags everything like you saw on that screen earlier. Ensures it's consistent across all teams as well. So make sure all your developers who are working on the same kind of programming language are all aligning to the same formatting. The last thing you want is half the team coding on one style and the other one coding in the other. And it really helps promotes those best practices as well. So encourages your developers to adhere to certain guidelines and have that high level of quality within the team, and also security and scalability, all those sorts of things that come with it. So linters are essentially the tools designed to analyze the coding language itself and align them to best practices. So linters are most commonly added to your IDEs, like Visual Studio Code or Visual Studio or JetBrains or whatever IDE you're using. Or you can add them, install them as an extension into your IDE itself. They also can be installed as like a standalone tools, like if you're using ESLint, PyLint, et cetera, et cetera. So there's different ways you can use linters to help you lint your code. So let's do a bit of, I'm all about demos, as you can probably tell. So let's jump into a little bit of a demo and add some lint tests to DevOps pipeline. Yep, I will be switching to my code, so just bear with me. Let me do that quickly. Okay. I'll switch back to my VS Code now, sharing VS Code. Cool. All right, let's come back. Alrighty, let me just close this down. All right, so I'm just going to open up any old pipeline here. So I've got just a pipeline template that deploys some bicep file here. Let me just try and minimize that a little bit. Cool. It's got some basic linting here. Let's see how we go with a bit of GitHub Copilot in agent mode. So I'll just clear my history from before. Okay, so I'm going to add a very vague, oops, that's not what I wanted. I'm going to add a very vague prompt by design, and then we're going to add a specific prompt. So you can just see the kind of difference. So I'm going to say add lint tests to this workflow. So you can see here, it's going to look at my workflow, and then it's going to try and do some kind of lint tests for me and add them. So before it did that, it actually said, hey, it's examining my entire code workbase. So I put an example workflow here that has nothing to do with my project. So this should be very interesting. So you can see in this case, it's actually got quite smart. It said, hang on, I need to understand your code base before I do anything with linting. So let me have a look. It's analyzed my code to see what programming languages it's using. And then it's going to say, all right, now I'm going to go ahead and add some linting that relates to that. So it was actually quite clever to give it some credit there. So you can see here, it's come back and say, look, I'm going to set up some node. I'm going to lint some application code and create a task here. And it's running ESLint, which is a valid linter. But it's added a bunch of code. And it's going to lint the server, and it's going to do a whole bunch of stuff. So that was actually quite clever for a basic prompt. It actually gave me more than I expected, to be honest. It's going to try and execute some things in terminal. I'm not going to go ahead and do that in the interest of time because we'll be here for a while and I can have lots of fun. So that is one example. I'm just going to undo that and say, no, I don't want you to make those changes. Now, if I add something a bit more specific, a bit more targeted, I just want to see what the, pasted an image there, did I? What the difference is if it returns the same results. Because in this case, I said, well, add an npm lint test to this workflow. So I was a bit more specific this time. So to get a bit of more targeted results. Now it could be even more specific as you would imagine, and the more specific and more context you give it, the better results you're going to yield. But in this case, I want to see what it comes back with. It may come up with something similar with ESLint stuff, which it has. Not quite the same, I don't think. A bit more different, a bit more comprehensive. It's got some lint summaries and stuff. So you can go back and forward with it. So that's just one way you can use GitHub Copilot and AI to add some lint tests to your workflows quite easily, especially if it's not something you're doing currently or something that's foreign to you. As you can see, GitHub Copilot is quite comprehensive and really good at helping with these sorts of activities as well. What I do use and what I kind of fall back to, I'm just going to undo that, is Superlinter. I'm not sure if anyone's familiar with Superlinter. Let me go back to a quick web browser and I'll show you. Again, apologies for chopping and changing. Right, Superlinter. If you just do a quick search for Superlinter, I just realized I'm not sharing my web browser, so let me just quickly do that. I'll share my entire web browser itself. So if you just do a quick search, I just type in Superlinter. It's usually the first one that comes up from GitHub. This is Superlinter. This is a really cool, nifty tool. It's also a GitHub action that you can view on the marketplace and then install. And it's actually a linter of linters, I like to call it. It kind of supports a whole bunch of different languages, which you can easily just quickly add to your GitHub workflow. And depending on whatever your code it is, it will detect it and it will do some linting based on these linters it's done. So you can see it's quite a comprehensive list of linters and languages it supports. It tells you what languages it supports and what linters it uses for those. So Python, PyLint, Flake, et cetera, Ruby, Rubocop, et cetera. So it's quite a, if you're not familiar with it, I do recommend just doing a quick Google and have a play around with it. It was done by, I think, by someone who worked at GitHub but not officially affiliated by GitHub. So yes, it was done by engineers that work at GitHub. It's my understanding, but you haven't used it. It's really cool. Yeah, and I can actually show you. I'll show you actually it live as well, so you can see what it looks like. In the interest of time, because I am running out of time because I do talk too much. So let me go back to my code. Actually, has this refreshed? There you go. There's my web app. It refreshed. It's working on Azure. So you can see now exactly how it was on the local version. It's now fully functional on Azure. There you go. Pretty cool stuff. And I'll scroll down. Yep. So pretty cool stuff, as you can see from the previous one. Just took a bit of time, but it all came together in the end. So if you go back to some other, I have prepared a pipeline that uses superlinter. So I'm just going to go ahead and run that. I'll show you what superlinter looks like live. So this is going to deploy a bicep file, Azure bicep file. And I'll show you what linting looks like when it does it as well. So I'll just give it a minute. So it is a container based. So you can see, for those who are familiar with containerized technologies, it will pull down the container and download it first, and then run the superlinter itself. So that's how it kind of works in the background. So you can see here, it's doing its thing where it's essentially downloading the container from the GitHub registry. So this is the GitHub action itself, and I'll let it do its thing. That might take a minute or so. So I'll show you what the code looks like while that's running. Superlinter. Here we go. So you can see this is it's a simple marketplace action, and you add the action, and you put in whatever GitHub token, and whatever. In this case, I was validating bicep, but there might be some other things you want to add depending on the properties and arguments you want to pass, like what's the default branch and all sorts of things. So there's lots of different options you can look at if you look up the GitHub marketplace action itself. And in this case, you can see it's quite straightforward, and that's all you need to do. So it's pretty cool. You can try using vibe coding to or GitHub Copilot to add that action. But I actually first tried to do that. It was using some really old legacy way of doing it, because it has changed in terms of when the superlinter first came out as a GitHub action that you could add to your workflows. So we're using that legacy method. So just be aware that you might get variances as well. And I actually tried saying, hey, use version. It was using an older version. So I said, hey, use version 7.3. And it's like, it didn't know about it at that point in time when I was building this. So just be aware those sorts of things can happen when using AI technologies, because they're really able to, refer to the training data that they currently have available, and that gets updated periodically as well. Okay, let's go back to that. Let's see how that's progressed. Yes, I'm sure it failed. Yep. So you do get some nice failure results there with superlinter. I made it fail by design. You can say, hey, in this case, it's used Chekhov and JSCPD, and they both failed. If you want to kind of peek under the hoods a little bit, yep, it scrolled right to the bottom for me. So you can see it's found all these sorts of errors. There's lots of errors. I'll scroll down. I'll scroll up to the top. But what's really cool is if we go to the top, it gives you a bit of a summary of results here. So you can see here, 8 checks have passed, 14 failed, and it didn't skip any. And now it's going to list all the 14 failures one by one. So you can see here, this is a Chekhov check saying, hey, my app service plan isn't zone redundant. Make sure it's zone redundant. So pretty cool. So it's actually using superlinter is actually using Chekhov, and Chekhov is an open source tool that will help you make sure your things are safe and secure and done to security best practices. In this case, my code is not by design. You can see it's found a whole bunch of different things. So it's really cool, easy way you can add this into your development workflow to make sure things are up to scratch. And you could see how easy it was to add just that superlinter to your workflow as well. I'm not going to go through all of them because there's a whole bunch of different ones. It doesn't have client certificates for incoming client certificates, et cetera, et cetera. So there's a whole bunch of them. So pretty cool and easy way to do so. Look at that, I got 7 minutes to wrap up. Lots of slides. I'll get through it as quickly as possible. Not too long to go. Okay, back to the slides and a couple of demos left, and then we can wrap it up for tonight. I clearly have way too much fun with this talk. Okay, so deploying AI infrastructure and models, sorry. Not too much slides on this. So one of the key things I want to call out is when you're deploying AI infrastructure to Azure, it should always be about make sure it's safe and secure from a networking perspective. We do that via private networking, make sure there's no public access, make sure it's safe and secure, use private endpoints, integrate subnets, all those sorts of things. And make sure when you, from an ingress perspective, if you're trying to access an AI workload, it should definitely be backed by a web application firewall. Make sure all the traffic, all the public internet traffic actually hits that as its first point of contact. And there's no other way to interact with your workload or your AI workload or your AI infrastructure. So it's kind of security best practices 101 there, but I do like to call it out. From a resiliency and observability perspective, rate limiting and metrics, definitely things you want to consider when it comes to AI workloads. Look at rate limiting to control usage, and integrate those things with Azure Monitor and Log Analytics, so you can get reporting on things like token usage and other critical metrics. So especially if you're doing a shared services model, where you've got lots of different apps using, OpenAI instance or AI Foundry and different models. How are you going to know who's using what or what's chewing up all your tokens if one app's working and another 10 are failing because there's your quota's been hit. Really think about limiting those apps and integrating your metrics into Azure Monitor. Also a good way to get cost control and chargeback and traceability as well. And also when it comes to resiliency, making sure things are highly available. Think about deploying OpenAI, for instance, deploy 2 of them, maybe do an active passive setup, those sorts of things. So if one hits, hit one OpenAI instance and the quota's a hit, it falls over to the next one, those sorts of scenarios. I just realized the notes are up. Apologies for that. Different architectures and models. There's typically two different type of architectures you can do, a shared model and a distributed model. You can deploy into a dedicated landing zone to support deploy your AI infrastructure into a dedicated landing zone to support your shared consumption. So different applications can consume OpenAI or AI Foundry and all those sorts of things. The opposite is a distributed model where you deploy one OpenAI instance that's dedicated to that standalone application, and that's the only thing that really consumes that. So they're the kind of 2 different architecture models. Now, in terms of what it looks like, you probably can't see that. Let me zoom in a little bit. So this is an example of a shared model where ingress will come through a web application firewall. That's usually in a platform dedicated landing zone. We use something like API management to help with rate limiting and filtering and all those sorts of things. And then that would pass it on, into this case, into our 2 different OpenAI instances. So this is one example of using a shared model. And then you'll have your application landing zone here, which will then consume those OpenAI instances when it needs to. So any workloads here would consume that. So when deploying AI infrastructure into Azure, just keep those considerations in mind. 3 minutes, ooh, that's going to be tough. Let me talk a bit about PS rule. I've zoomed in here. PS rule for Azure. Don't worry, there's 3 slides, a couple of demos, and we're done. I might go a few minutes over. So what is PS rule for Azure? It's an open source tool for validating Azure resources against best practices. really helps governance and shift, do that whole shift left from a security and compliance perspective. And the good thing about it, it's based on Azure's well-architected framework and cloud adoption framework. So why does it really matter? It really helps automate compliance checks on your, if you're doing ARM, Bicep, Terraform, any kind of IAC. It will really designed to work into your CI/CD pipelines, whether it's Azure pipelines, GitHub Actions, those sorts of things. And the good thing is it is customizable, and it does have a bunch of out-of-the-box governance rules for faster decisions if you don't know what to look out for. So how easy it is to plug in PS rule to your Azure DevOps pipelines. It's really easy. You just add it into your pipeline as a CLI or task. It will then validate your templates as a part of pre-deployment, and then it will fail those builds or notify if things are non-compliant, really similar to how SuperLinter worked. So how can you use it? So you can use it like heaps of different ways. Some kind of commonly used ways are you can use it to detect like if network security groups are really overly permissive and allowing lots of traffic in, it can detect that before you actually deploy that and help it prevent that and catch that before it actually hits production. You can actually use it to enforce naming conventions. That's everyone's favorite. It can also use it to catch missing diagnostic and Azure monitoring settings to make sure everything's monitored and enabled by default as well. All right, a couple of demos, and then we can kind of I'll leave it time for some questions as well. I'll just do a quick demo on the PS rule for Azure. I have yes, I will be switching back to my web browser again. Bear with me. Share. Cool. So I did prepare a pipeline as well, a GitHub Actions pipeline. So I'm going to go ahead and kick that off. Now this one, I'm just going to kick it off. I'll show you what it looks like from a code perspective, and then we can see what the live results look like as well. So PS rule, if I scroll down, past it. PS rule is right here. So here it is, and I'll zoom in a little bit so you can see it much better. So PS rule essentially is, I'll just highlight it, the first line. So PS rule, again, similar to SuperLinter, is just a GitHub action that you add, and similar to like something like Azure DevOps Pipelines as well, where you would come in and just add the task, put in some parameters and for the GitHub action in this case to function, and then it'll output the results in this case in Serif format that you can kind of look at, or you can choose different formats as well. I chose Serif being the most typical common one used when it comes to testing and test results, but I think it does support like JUnit and NUnit and all those sorts of things. And you put out the things you wanted to test, and away it goes. So you can see it's quite easy. It's quite easy to integrate and add to your DevOps pipeline. Is really simple, and it'll yield you some really cool results, like we're about to see. So let's switch this one. Cool. I'll cancel that workflow because I don't want it to deploy anything. So we see here it's going to run the PS rule. I didn't set it to fail because I can, but in this case I didn't. But I just wanted to kind of show you quickly what the kind of differences between PS rule for Azure and SuperLinter. I know you could obviously use both, or make your own decision on what you think is best. But you can see here it gives you a bit of a summary. You can see it's got PS rule, and it tells you here's all the tests I ran. These all passed, and this one specifically I made it fail on purpose. It failed, saying, hey, the Azure template's not using descriptions. It gives you a recommendation saying use descriptions in your Bicep template. Here's a link to that rule and what it means, and all that sort of stuff. And you get a bit of a summary at the bottom. SuperLinter does the summary at the top, but they both work quite similarly. They just do kind of two different things. This one's purely for Azure, where SuperLinter is for a whole different bunch of different programming languages. So you can see how you can easily, just by adding one simple action, can really help improve the posture of your code from not only security, but from coding standards as well. 3 minutes over, but I think I did it right. Let me just quickly share my slides again. The reason I want to do that is I'm all about QR codes. So feel free to scan that QR code. If there's any questions, I think we'll answer them now.
Thanks, AJ. While other people actually just going to actually scan your QR code to send the questions, I can see some questions in the chat, which are bring on the screen. You can see them. So a very long question from Matty. So
yeah, cool.
Do that.
All right, so I'll just read the question out and then I'll answer it. So a common issue I've observed when auto-completing or writing auto-provisioning scripts for Azure using Terraform is that AI often uses depreciated options, modules, resulting in many attempts to get scripts functioning correctly, especially for conditional logic. Yes. This is due to fast pace of changes in the cloud environment. What's your advice on how to handle this? Yes, I have seen this not only in Terraform, but lots of different things I do, and I think I kind of touched upon this as well. Yes, it is going to be dependent on its training data available. So you got to have to keep that in mind, that AI can only reference its training data that it has available today. A good thing, I don't know what AI tools you're using, but I use GitHub Copilot primarily. There's lots of different prompt files out there. If you Google awesome Copilot, there's a lot of Copilot instructions. I'll put it in the chat in a minute. Prompt files, chat modes, and Copilot instructions you can do. And there's ones I know specifically for Terraform to kind of dictate and tell your Copilot how to do things for Terraform specifically to help avoid those sorts of things from happening. So I recommend, tailoring and using those mechanisms that are available to you to kind of tell and essentially tell and train the AI agent how you want it to, analyze and help you with Terraform code. I'll put that in the chat in a minute.
Awesome. Thanks, AJ. And probably second question from Matthew again, after you typed that in the chat.
Yeah. Yep, go for it.
Yep, it's on the screen. So would you please recommend a resource for PS rule?
Would you please recommend a resource? As in the link to it? Or I'm not sure I understand the question. A link to PS rule, or like a resource to use on PS rule? Like what's a typical resource? I mean, I would use it for any kind of, if I'll answer the latter, and then if it's not, I can send you a link for it too. But yes, for PS rule, in terms of resources you can use, like what's the recommended resources? Anything for Azure, like PS rule. I mean, there's PS rule for in general as well, but there's also PS rule dedicated for Azure. So if you're doing any work in Azure, I would recommend using PS rule for Azure and adding it. So if you're using DevOps pipelines to deploy anything to Azure, no matter what it is, app services, APM, AI, storage, ISC, whatever you're doing in the Azure ecosystem, if you're using a pipeline to deploy it, as I showed you, it's really easy to add PS rule to your pipeline. It just takes less than a minute, and it will actually pick up those things for you. So anything you're doing in Azure is my answer.
Yep, cool. Probably I'll just show the URL that you posted and actually in the comments for everyone can see, if in case if they cannot see it actually in the chat, or if they are not in the chat, they can see it live later.
Yeah, good idea.
All right, cool. And maybe one strategy type of questions I would say, AJ, if you can answer. So how do you see actually AI functionality changing the way of the DevOps teams operating in the next 2-3 years potentially?
Probably big time is my answer. It really has. I think it really has already. It's really changed the dynamic on how we approach tasks now, and you will see from like how fast and rapid things are changing and new things are getting introduced. Like like as I touched upon, like GitHub Copilot started as code completion, then introduced chat, then introduced agents. We have a GitHub Spark where you can just type in and say, "Hey, if you want to build a web app of sorts, you just type in your idea and it'll build a prototype for you within minutes," right? So it's really changing how we do development ourselves. It's going to be more and more on how we interact with AI and how we leverage AI, and it's all about, I think it's going to be all around, how good you are at writing prompts, and you're going to be more focused on writing more specific prompts and prompt files and things like that, instead of focus on writing the code. I mean, the code there's still going to be a code element, and you're always going to need to know how to code and how to understand code and read code. I don't think that's going to go away anytime soon, but I think you'll be less on generating the code yourself, at least initially anyway. So, especially a lot of that boilerplate code, I think what's going to happen is I'm going to say, hey, I need you to write me a bicep template or a .NET function to do X. Instead of you writing the code, you traditionally, as we would go to GitHub Copilot and agent saying, do this for us. And you would write a prompt or use your prompt files or whatever, and then it would generate that. And then you would probably do one or two different things. You would just take it from there and run it, make your changes and tweak it how you want it to, or you would keep going and prompting with the AI tool. So I think it's really going to change the dynamic on how we work in the next few years. I think it really has.
Yeah, I agree. So as you mentioned, I think you're on the same page. Probably not just for the coding purpose. Prompt engineering these days and a skill to get at how to prompt actually the AI tools to get the most value or outcome out of those tools. That's definitely the important things everyone should consider. So no, I think it was a great session. Thank you so much. I'm not sure if anyone just scanned your QR code, have some questions, but I'm assuming you can reach out directly to them. Is that right?
Yeah, so that QR code will take you to my LinkedIn. So feel free just message me on LinkedIn. Yeah, I'm more than happy if you've got any questions or anything you want. I'll get back to you as soon as I can. I've also put a link in the chat for the PS rule for Azure as well. For those, you can just do a quick Google anyway, but I figured it's there. But yeah,
I'll bring it up on the screen as well.
Yeah.
So for the people watching the recording later. So thanks again, AJ. Great sessions. Thanks for sharing your knowledge with everyone here. And everyone, just feel free to be in touch with AJ directly. And if you have any questions outside of these sessions, reach out to him directly. Thanks again being with us and with Microsoft Hero. We had another session. Hopefully we're going to have more sessions during September with more experts and great speakers. Thank you, everyone. Have a great day, night, wherever you are. Thank you. Bye.
Thanks all. Bye.